introduce me? Okay, here we go.
Yes. Okay. Good night. Here is David Dutton with us. Here, David is the author of Mule in Action, first and second edition. Also has written another book, RabbitMQ Essentials. And this opportunity, David will talk about the Call Me Never, his last talk in DevOps Vancouver, that I think was a few weeks ago.
That's correct.
Okay, so David, thank you for, first of all, thank you. So you can start.
Thanks. Thank you, Edu. Thanks for having me. So I'm gonna hide my pretty face, and I'm actually gonna start sharing my screen so you can see my presentation. Thanks everyone for joining. So let me see if I press the right button here. Screen share, sharing. All right, you should see my screen now. So as Edu said, this is a replay of a presentation I gave a few weeks ago during DevOps Days in Vancouver. During DevOps Days, I only had 5-minute slots to go through these slides. So what I'm going to do tonight is go through these slides again, but go through the longer version of the slides with a little more content and a little more time to actually detail what I wanted to say about. So this presentation is really about I'm going to talk about what we've done at Bounce when rebuilding one of our most critical application, and the different things we've done to try to build an application that would actually be kind with us and would not wake us up at crazy hours in the evening or in the night. So that's why this presentation is called Call Me Never, because hopefully the application will never call us to say there's a problem. So as Edu said, you probably know me through a couple of books I've co-authored and authored. I do lots of other stuff around open source. If you follow my Twitter handle on the top and then different links, you'll be able to find out anything. So as I said, this talk is in the context of what I'm doing at Unbounce. I'm the director of software architecture at Unbounce, and Unbounce is a marketing automation company. We provide a toolkit to allow marketers to build landing pages, and we provide all the tools around these landing pages, so A/B testing, statistics, integrations, and this kind of stuff. So a big aspect of these landing pages is actually serving these pages. And currently, we have around 5 million visits per day on our pages. Actually, the pages of our customers, and counting. The traffic is constantly increasing, and so this actually is what we have rebuilt. And what I'm going to talk about is the page serving infrastructure. So basically, all the infrastructure that's involved into selecting a page variant, rendering it, capturing stats, and delivering stats. So it's a critical piece of software, and we wanted to rebuild it while aiming pretty high, aiming for 5 nines availability, and at the same time a 100-fold increase in traffic, which we think is going to come in the coming years. So like 5 nines, it's around it grants you something like 6 seconds of downtime per week. So it's not a big margin. And so going through this project, basically we went through the 2 states that every programmer knows. Like one state is I'm a god, and like we're using all the awesome technologies. We're using Netty, we're using Hazelcast, we're using reactive extensions. So this is great. And on the other hand, the other state is I have no idea what I'm doing, because basically, unfortunately, we haven't reached yet our goal of 5 nines. We're between 4 and 5 nines currently. So in the process of building this new software, we've met some issues, and we've put some practices in place, and this is what I'm going to detail now. Basically, I'm going to talk about the different things we've done around these 4 main axes of readiness, graceful degradation, recovery, and then strengthening of the application. And then, without further ado, the first thing I'm going to talk, and this is something that was discussed just before my presentation during DevOps Days, it's the necessity to go through load tests. And it sounds, yeah, it sounds obvious, like, right? Every developer should do load tests. But I don't know, maybe it's just me, but there is this, when we build software, this software is like a little baby, and it's a little tough to throw lots of requests at it and torture it. And so I don't know, maybe it's just me, but typically I've seen developers are kind of hesitant when it comes to torturing early and daily the software they are creating. In any case, I think load testing is a great practice, and we are using both Apache Bench and Apache JMeter. Apache Bench is awesome when you want to validate that, like validate the basics. Basically, if you want to throw 10,000 requests with 50 concurrent users on an endpoint, on an HTTP endpoint, and see what's going on. And something as crude as that, at least a couple of times, caused some very interesting issues in our implementation, and actually also in libraries we depend on. So it takes like a couple of seconds to run an Apache Bench load test, but the payoff is huge. Then, of course, when you need richer scenarios, you're going to use a tool like JMeter or Gatling. When I say richer scenario, I'm talking about things like hitting different endpoints, for example, different paths in your web application, chaining these calls, randomizing the data you provide, and all this kind of stuff actually, while being under load, also increases the stress on your application. Like the randomization, for example, is an interesting trick to prevent caching, to replay the same request all the time. So if you want to bypass, depending of course on your application, but putting randomization at the right place allows you to bypass caching and actually hit hard on your application. So testing is great. Inferring stuff, deducing stuff based on the testing is awesome as well. Like in our case, we typically run Visual VM and Eclipse memory profiler after a load test, during or after a load test session, during when we want to look for thread contention. And as you can see in the above picture, we had some issues, like all this red was thread contention that we've solved in the meantime, and in the bottom it's a memory analysis after a load test, and it's great to actually use this kind of tool early on and regularly actually to find out what's going on in your application. And still in the readiness side of things, another thing we've done is replaying access logs. So as I said, we have something like 5 million requests per day, and these requests will hit almost anywhere and everywhere. So it's something that's very hard to simulate in a load test, when you can randomize, but you can't really make all the crazy and all the diversity of requests that your application will receive, especially in our case, where we serve so many different pages on so many different paths. So we found out that taking an access log, like a full day of access logs, and replaying this in a couple of hours on our server allowed us to detect some pretty interesting issues. thanks to the actual breadth of the data used during this test. It's not that easy, of course, because, for example, post requests, you won't find the body of post requests in access logs. So you can't replay all the post requests. If it's a post with all the data in the URL, then that's fine. And also you need to qualify errors. Like, for example, something may fail, and it's fine if it fails. Like, for example, a page, in our case, an endpoint was returning 200 the day before, and the day after it returns 404, and it's actually valid to return 404 at this point of time when you do the replay. So it means that if you follow this path, you have to do some qualification of any kind of errors you get. But it's something to consider, because especially when you transition from an existing system to a new system, you can then take the access logs of the existing system and start hammering the new system before it goes to production. So that's something we used. And yeah, when I say welcome to the internet, this is the kind of crazy things that constantly goes on our pages. Like bots and hackers will constantly try to figure out, hey, are you running WordPress? Do you have an admin page? And we also do crazy things like put some random SQL commands in host headers, and even in, I think I found a user agent. They were trying to pass some queries, and some nasty queries in a user agent header of requests. So this is the kind of stuff that you can also get ready for if you get some production logs and play that on the new app you're building, because this is the kind of stuff you will never make up. So that's all for the aspect of readiness. Now I'm going to go into the aspect of degradation and graceful degradation. And so so I'm not going to detail everything we've done, but just a few points. And one of them is decoupling the different systems and subsystems. And use queues and topics for that matter. We are running in Amazon Cloud, so we are using SNS and SQS. The decoupling you get is really about basically removing the time dependency, the time dependence that can exist between systems. For example, we typically have around a second delay between the time a visitor hits a page and the time when our statistics are updated, so our customers can gauge the success of their particular page. Typically, we are around 1 to 2 seconds. But when suddenly there was an election somewhere in South America, I forgot, but one of the candidate page suddenly receive a huge spike of traffic. Like, if you look at the chart on the left, you see that the regular traffic has been dwarfed by the spike. Like, at some point we reached 20,000 requests per minute on this very single page. So if our stat system would have been timely coupled with our page serving system, we would have put a crazy pressure on the stat system. But because we've decoupled these systems with a queue, you can see on the right that the amount of messages piled up in the queue is going up as the page views, as the page are getting hit, and then progressively as the traffic decrease on the pages, then the queues are being consumed and processed. So when this happens, then of course we can't guarantee anymore the 1 to 2 seconds delay on stats. Like, suddenly we'll have minutes of delays. But the good thing is that we're degrading gracefully. We're not falling over. We're just delaying stuff. And this is something you really want in your application as much as possible, is whenever you can shed load, whenever you can delay anything, do it, because it's reducing the pressure you carry on dependent systems if you don't do it. Another thing we've done is short-circuiting using Hystrix, Netflix Hystrix, which is a very smart circuit and very configurable circuit breaker to short-circuit blocking IOs. And it's very important keep your threads busy and not hold them waiting on stuff. And especially for us, we have to serve pages very quickly. And in any case, if anything is going wrong, like for example, if reaching S3 is very slow for any reason, or if there is, as we've seen, if there is some communication issue between EC2 instances in the same or in the different AZ, and suddenly things are getting slower, being able to short circuit and fall back to default values, or if not, at least fail or bail with like a 506 or 503 status code, so the load balancer knows, whoa, there's something wrong. Being able to do that and not block everything in your application is very important. And to give an example, like this looks like a very basic thing, right? I'm just getting a value out of cache. This cache has an API that actually implements map, Java util map. So nothing could go wrong with that stuff, right? Unfortunately, this cache is a distributed cache, and this get actually hits the network. And when things are going bad between nodes in your cluster, this get can actually take a lot of time. Hitting this supposedly in-memory cache can actually be slower than hitting our main your primary data store, which is S3 in our case. So basically, we've wrapped this call and similar calls with historics to short circuit very quickly if anything blocks by accident there, and fall back to going to the primary data store. So when I say beware of benign code, sometimes, I mean, this is the danger and the greatness of abstraction, right? The greatness is that this simple get, you don't know where it's going to fetch the data. It's going to be maybe local, maybe remote. Beautiful, it's nice abstraction, but the danger of this abstraction is that it pretends the network doesn't exist. Like this is this common fallacy that remote calls are always free and always transparent, and so this is why I'm saying beware. And now the next aspect we've worked on is having a system that is able to self-heal and recover from transient failures. This is very important, especially in the cloud. The resources you depend on, like the other servers, like even the resources provided by your cloud provider, will not always be there. And the illustration you see here show like rate of errors, mostly dealing with S3 and SNS and SQS. And we don't see much errors, like we don't see many of them. Like typically in a typical week we'll see probably less than 20, 25 per week issue talking to SNS. But since we send very important data over SNS, we don't want to lose this data. So these errors you see spiking on the two graphs on top. What we do to deal with this kind of error is we actually accumulate in a local file system any message we've tried to dispatch to SNS, and then we retry asynchronously. And what you see in the graph in the bottom is actually the number of locally accumulated data. So when on our monitoring system, if we see a spike like that, we know that for a while one of our instances was incommunicado. It was unable to reach Amazon SNS, and decided to locally store the data. And as the little red spike disappears, it means that our instance has correctly reprocessed this data. And you see that again in this same it's a similar diagram where you see data being accumulated up to the point, like when you see it plateauing like that, it's because we've decided that this particular instance was having too many issues to communicate with SNS, and we took it off the load balancer. But then we let it running until it eventually caught up and sent the data it locally accumulated. So so this is why this strategy of retrying asynchronously, being able to automatically self-heal and having our systems eventually become consistent from the data standpoint, has also saved our bacon more than once. In the aspect of recovery, another important thing is maintaining stable state. And so which is basically persisting state in a node until you are certain that if it needs to transfer this state to somewhere else, you keep the state local until you are certain that it's been correctly transmitted somewhere else. In our case, for example, we keep a trace of all the access logs, for example, out of which we build our stats. We keep a trace of from submission data locally. And the good thing with that is when you have a stable state, you can replay it. So when things go crazy bad downstream, then you know that you can replay whatever happened and has been lost. You can replay it from the stable state that is accumulated in the upstream systems. And having this stable state is really the difference between having an issue, having the world on fire, and having no way of recovering, so you have to fix everything right now. Or having the world on fire, but knowing that things are getting stored somewhere, and you will have a chance later when everything is fixed, to replay and rebuild the eventual state of your system. So this is something that I strongly advocate as well. And in the last aspects of this presentation, I want to talk about strengthening an application. An issue so the first point here is around health checks. And so typically when you deploy an application, you're going to put it behind a load balancer. And the load balancer will need to estimate the availability of your application, and typically this is done by calling a specific endpoint on your application to check that it's healthy. And it's very important that this health check is actually healthy itself. It sounds to give you an example, this is a chart showing the instance count of our page servers in one region, and the health check itself was having an issue, and the health check was reporting the servers as being not available by accident. And so we were seeing our servers entering into production and being taken out of production by the ELB, and these instances flapping in and out of the ELB pool until we realized that the issue was in the health check itself, that this health check was not able to do its job under certain circumstances. So having healthy health checks is really important. And the fun part is that I wrote a blog about that many years ago, and it seems like I forgot my own lessons because this time, well, anyway, this is like the two states of a software developer, right? This was the bad state. Another aspect is around coding defensively and logging abundantly. So, of course, like everybody knows now about this this concept of letting things crash, right? That's coming from Erlang, where you actually let errors percolate up the stack until they hit a supervisor, and then the whole subsystem that has been affected gets restarted. You can find now these same principles in Scala Akka, inspired by Erlang. The thing is, there are still some places where you want to catch stuff, at least at the very least to log things, and also to produce reasonable responses. So there are places where you want to be extremely conservative. and usually catch very wide at a higher level in an error, in a call stack. So you can produce like something like a 500 or 503, depending on the error condition, the exception you quote. Use a status code that is more relevant, and also log. When I say log abundantly, I really mean also log smartly, right? Like for example, in our case, we've added a unique request ID to all the requests. So if anything goes wrong, we want to make sure that we're going to log this request ID. So when we log stuff, we want to make sure that we actually log enough context. Like logging an exception is not enough. Logging an exception with the actual request path and hostname and whatever, then this is getting better because now you get some more context. So so yeah, that's the two aspects around this. One thing I need to add is that if you log, you will mostly be running a distributed system in the cloud. So if you log stuff, you will need to aggregate logs. And this is also another case where using unique request IDs, for example, will help you a lot, is because it's going to allow you to do some forensics and be able to see what happened to a particular request and the data related to this request as it's been processed through the different distributed systems. So this is the kind of stuff you want to log, you want to carry around, pass in messages, pass in further downstream requests, and have all the different subsystems and related systems log smartly. So when you aggregate all these logs, then you can make sense of what happened. This is essential in distributed system. This is essential with asynchronous systems. So yeah. And last thing we've learned is that failure will occur, and failure is actually an opportunity. Every time we had an issue, we've created more tests. We've created new tests, like for example, created a complete acceptance test suite that does a combined load test and verification of statistics. So anytime we've found an issue, instead of despairing, we thought, okay, that sucks, we fix it, but we also automate everything around this issue so it's not going to happen again. And also, actually in the process of creating more tests, you may be catching other things that haven't shown yet in production, but that could actually show up sooner or later. So, so yeah. Well, that's the end of my slides. So I don't know how we can do Q&A through.
Oh,
I don't know how we can do.
Yeah,
Back to you, Edu.
Can you repeat, please?
Excuse me?
Can you repeat?
I said back to you. I don't know how we can do Q&A or whatever.
Oh, great quote about keep calm and learn lessons. I think that this is important in every topic in each company. So that's interesting. All the topics that has been taken into account at Unbounce, the company where you work. So thank you to share with us some interesting topics. There are people viewing through the YouTube, so I think that they can now do some questions. So, but I think that we have learned a lot with that.
My Twitter handle is in the slides, so if they scroll back in the presentation, they can find it and they can get a hold of me on Twitter. I'll be happy to answer any question.
Yeah, yes, I will publish your slides, the link of your slides in the YouTube, so will be available for everyone.
Okay, cool.
So thanks to share with us your last presentation, David. So we hope to stay in touch in the future and talk to another topics like your favorite pets, mule and rabbit. So
I like funny animals.
yes. Yes. Thank you again, David. So we will keep in touch.
Okay, thank you.
Okay. Thank you.
Bye.